Sean's toy box is too small to fit all of his toys. His mother commissions a carpenter to build a new toy box. She does not take Sean's original toy box to the carpenter, but describes it to the carpenter as about 3 times as long as it is wide and about half as high as it is wide. She asks the carpenter to increase the capacity of the toy box by at least 40%. The carpenter draws up the plan seen below with X representing the depth of Sean's original toy box in inches. Will the carpenter's plan meet Sean's mother's request if the width of Sean's original toy box is 16 inches? Justify your solution and evaluate the problem-solving process. Okay, so looking at the picture, we can see the original toy box with its width of x, the length of 3x because it says it's 3 times as long, and then the height of 1/2 x. And then the carpenter is proposing adding 3 inches to the length, 2 inches to the height, and 1 inch to the width. And so that's just understanding the question now is really, is this new box at least 140% bigger? What we could do is we could find an equation for the original box and multiply it by 140%, which in decimal form would be 1 4/10. And then we could see, just plugging in the value 16, if the original box had the volume, and then we could see with a 16-inch width, and then we could calculate the carpenter's new box with a 16-inch width and see if that width will work for being bigger than 140%. And so just coming up first with an equation for volume, the original volume was the width x times the length 3x times the height 1/2 x. And then multiplying that together, then 3 times 1/2 is 3/2, or that's the same thing as 1 5/10. And then x times x times x is x cubed. And then if we want that to be 140% bigger, we can just multiply that by 1 4/10, since that's the decimal form. And so multiplying each side by 1 4/10, then 1 5/10 times 1 4/10 gives us 2 1/10 x cubed. And so that should be our new volume. The original toy box was 16 inches, so that was our width. Then we can just plug this in to our volume when it's 140% times as big. So 2 1/10 times 16 cubed gives us 8,601 6/10 inches cubed. This would be the volume that our new box needs to be, and then if we find the new box that the carpenter proposes, then that would be, we can call that n of x for new box. That's going to be x, the width, but then he adds 1, then the length plus 3, and then the height plus 2. And so we could simplify this all out and multiply it, and that's actually going to be in our answer. But just for time's sake, we really don't need to do that to get our answer. We can really just plug it in as is, plugging in 16 to see if it ends up being greater or equal to this other number that we came up with. So plugging in 16 here, then we get 8,670 inches cubed. So you see here, this is going to be greater than just 40%, and so the carpenter's box will work. So let's go ahead and summarize our answer. The volume of Sean's original toy box can be represented by v of x equals 1/2 x times 3x equals 1 5/10 x cubed. To increase its volume by 40%, multiply v of x by 140%. 1 4/10 v of x equals 2 1/10 x cubed. If the original width is 16 inches, then the volume of the new toy box must be at least 1 4/10 times v of 16 equals 2 1/10 times 16 cubed equals 8,601 6/10 cubic inches. The volume of the carpenter's plan for Sean's new toy box can be represented by n of x equals 1/2 x plus 2 times x plus 1 times 3x plus 3 equals 1 1/2 x cubed plus 9x squared plus 13 1/2 x plus 6. N of 16 equals 8,670 cubic inches. Yes, the carpenter's plan will meet Sean's mother's request if the width of Sean's original toy box is 16 inches, because 8,670 is greater than 8,601 6/10.